Good day, everyone. My name is Alexander M. Apilado. In today's presentation, I'm going to present the Data Communication Network Design. Data Communication Network Design refers to the process of planning and creating a network infrastructure that allows for the transfer of data between multiple devices or nodes. This involves determining the network topology, selecting the appropriate hardware and software components, and configuring the networks to meet the requirements of the organization or business. In network analysis phase is a crucial step in the process of designing a new network or upgrading an existing one. This phase involves analyzing the organization's requirements for network functionality, performance, and security to determine the best approach to designing the network. First, identify the stakeholder. The first step in the network analysis phase is to identify the stakeholder who will involve in the project. This includes IT staff, business users, and other relevant stakeholders who will be impacted by the network design. Second, define network requirements. Once the stakeholders have been identified, the next step is to define the organization's requirements for the network. This includes understanding the types of devices and applications that will be used on the network, the number of users, and the locations of users. Conduct a site survey. A site survey involves gathering information about the physical location where the network will be deployed. This includes understanding the building layout, cabling infrastructure, and environmental factors that may impact network performance. And then fourth, analyze existing network infrastructure. If the organizations already have an existing network infrastructure, it is important to analyze it to determine its strengths and weaknesses. This can help identify the area of improvement in the new network design. And then fifth, define network topology. Once the requirements have been identified, the next step is to define the network topology. This involves determining the physical layout of the network and the types of devices that will be used, such as the switches, routers, and firewalls. Develop a network design. Based on the information gathering during the analysis phase, a network design can be developed. That design should take into account of an organization's requirements, as well as best practice for network design and security. And then lastly, implementation phase. The network implementation phase is a stage in which the planned network design is put into action. This involves setting up the network infrastructure, installing and configuring the necessary hardware and software, and testing the network to ensure its functionality and expectations. In building block network design is a network architecture that uses modular components to design and build a scalable, flexible, and easily manageable network. It involves breaking down the network infrastructure into smaller and easily managed building blocks, each with a specific function or purpose. And here are some components of building blocks network design. And then first on the list, we have a core layer. The core layer is the backbone of the network and provides high-speed connectivity between all other network components. It should be designed for high availability, redundant component, and multiple paths for data flow. And then next, we have the distribution layer. The distribution layer provides connectivity between the core layer and the access layer. It includes network devices such as switches, router, and firewalls that are used to enforce security policies and manage network traffic. And next, we have an access layer. The access layers provide connectivity for end user devices such as computers, printers, and phones. It includes switches and wireless access points that provides access to network and enforce security policies. And then we have management layer. The management layer provides tools for managing and monitoring networks. This includes the network management software, login and monitoring tools, and other applications that helps manage the network. And then approaches and benefits. By choosing the selecting and the right approach to network design and benefits of effective design, organization can create a network infrastructure that meets their specific needs and supports for the business goals. For scalability, the modular designs allows for easy expansion of the network as needed without disrupting existing network component. And then flexibility. The designs allows for different components to be added or removed as needed, allowing the network to adapt to changing requirements. Manageability. The modular design makes it easy to manage the network as its component can be managed separately. And then resiliency. The use of redundant component and multiple paths for data flow ensures that the network remains available in the event of component failure. And then we have the phases of design. The network design process typically involves into 3 phases. We have a needs analysis, technology design, and the cost assessment. Until it process of the cycle through all the 3 design phases is repeatedly until final design is decided on. In this process, it involves understanding the business goals and objectives of organizations, as well as the technical requirements for the networks. The need analysis phase typically involves several steps. By understanding the business requirements, this involves identifying the network business goals, objectives, and strategies of the organizations. It is important to understand how the network will support the business and contribute to the achievement of these goals. Identifying the technical requirements. This involves understanding the technical requirements for the network, such as the bandwidth, latency, and availability. It is important to understand the types of applications that will be supported on the network and their performance requirements. And next, by conducting a network assessment. This involves reviewing the existing network infrastructure, identifying any gaps or deficiencies, and determining the needs to be added or upgrade to meet the requirements identified in step 1 and 2. Okay. And then by creating a network design, and then based on the needs identified in the first 3 steps, a network design can be created that meets the requirements of the organization, and this includes selecting the appropriate hardware and software component, configuring network protocols, and addressing SIEMs, and creating a plan for network security and disaster recovery. And then we have also the Goal of network design. The goal of network design is to create a reliable, scalable, and efficient network infrastructure that meets the current and future needs of an organization. As well designed network can improve business operations, enhancement productivity, and enable new services and applications to be deployed. A network should be designed to provide high availability with a minimum downtime and disruption. This requires redundancy and fault tolerance in the network infrastructure, as well effective monitoring and management tools. And we have also the scalability. A network should be designed to accommodate growth and changes in organization needs. This requires a flexible architecture that can be easily expanded and upgraded. And then we have security. A network should be designed to protect against unauthorized access and data breaches. And this requires implementing security policies, access control, and encryption mechanism. And in performance, a network should be designed to provide high performance and low latency with adequate bandwidth and mechanism to prioritize traffic. And then for manageability, a network should be designed to be easily managed and maintained with tools and process to monitor and troubleshoot issues. And then last, cost effectiveness. A network should be designed to balance cost and performance with consideration given to the organization's budget and resources. Okay, and here are phases of design. So as shown on the screen, it has a needs analysis, technology design, and cost assessment, and cycles through by refining the outcome of each phases until the final network design has been decided. Defining the geographic scope of a network. It pictures the physical extent of the network infrastructure that is being designed or analyzed. It includes the location of the network devices, such as the router, switches, server, and endpoints, as well as the cabling, fiber optics, wireless links, or another network media that connects them. And then by defining applications and users that will be use the network, by defining application softwares, programs, and services that runs on the network and are used by users. Example of applications includes email, file sharing, video conferencing, and web browsing. Each application has different requirements for bandwidth. To produce a logical design that describes the network elements will be needed to meet the organization's needs, also describes the high-level structure and component of a network without going to specific details of how the network will be implemented to create a logical network design that meets the organization's needs. Breaking the network into three conceptual parts based on the geographic and logical scope. We have the access layer, typically refers to the layer hierarchical network design that provides network access to end devices, such as the desktops, laptops, printers, and other network devices. And then distribution layer is a layer in a hierarchical network design that provides connectivity between the access layer and the core layer. Server as the boundary between the access layer and the core layer, providing the centralized location of implementing policies and routing decisions. And we have also the core layer. The core layer is a layer in a hierarchical network design that provides high-speed connectivity between different parts of networks. Okay. But note all layers presented in all network are not equal. So some of networks may not have distribution layer. On new network project or network upgrades, it typically involves measuring key network performance metrics such as latency, bandwidth, utilization, packet loss, and throughput. And this information is collected over a period of time to capture variation in network traffic and usage pattern. Provides baselining in against future needs. Once the baseline performance has been established, it can be used to identify areas where improvements can be made and for new network design. And then we should have a clear picture of the following sequence of operations, processing time, work volumes, current network, and existing cost, and user management needs. Design process is the practice of planning and designing a communication networks. Starts with identifying business and technical requirements and continues until just before the network implementation stage. Okay. And it starts at the highest level by beginning the layout of one connection location. Individual level location, if the design is connected to metropolitan area network, campus area network, LAN, and wireless LAN, and it's recommended usually as a series of diagram and one for each location of type of network was chosen, and then gathered information and characteristic of the environment, such as the legal requirements. Depending on the network locations and types of the project, there may be various legal requirements that needs to be considered in example of some jurisdiction. This may be specified zoning laws or land use regulations that dictates what type of building can be constructed in particular areas if requires. And we also have for consideration the regulations. There may be also specific regulations that needs to be followed in the design and construction if may require. For example, there are maybe regulations related to fire safety, accessibility, or environmental impact that needs to be considered. And then the building codes. Building codes are sets of standards that dictates how the building administrators should allow the construction if required. And now we go through the designing of network performance. Okay. Designing for network performance is critical to ensure that a network operates efficiently and effectively, providing the fast and reliable access to resources and applications. And here are some keys when designing for network performance. The network management software and standards, policy-based management, traffic analysis, service level agreement, device latency and device memory, load balancing, content caching, and content deliveries. Managed network is a standard device to monitor traffic flows, monitors its status and other devices connected, to record the various data on message it processes, and sends this data to managers' computers on a request, and sends alarms if a critical situation detected, such as a failing devices or unusual increase in traffic. Problem detected and reportedly by devices themselves before problems become serious. And we have also the hardware and software, the network hardware devices, and the network management softwares. Here are the main different types of networks. We have local area networks. A LAN is network that confined to a small geographical area, such as a single building or a campus. It is typically used to connect computers, printers, and other devices to share resources and data. We have also wide area network. Is a network that covers a large geographical area, such as a city, country, or even multiple countries. It is typically used to connect different LANs and enable communication between geographical dispersed locations. We also have a metropolitan area network. Is a network that covers a larger than a LAN, but it's smaller than a WAN. Typically covering a city or a large campus, it is typically used to connect multiple LANs within a geographic region. We also have wireless local area network. Is a wireless communication technology such as a wireless to connect devices instead of physical cables. Lastly, we have a campus area network. It is a network that covers a specific geographic area, such as a college, campus, business park, military base, and usually made up of combination of LAN, MAN, and other network technologies interconnected to create a large network that covers the entire campus area. So these are just some of the main types of network, but still there are some like clouds, what else? VPN. Okay. And now let's dive into the logical types of network that may require a mandatory application and hardware in network design. First, we have the server farm. A server farm, also known as the data center of a server cluster, is a collection of computers and networking hardwares that is used to provide centralized data storage and processing power for an organization. In network design, a server farm is typically used as a centralized location of hosting applications, data, and services that are accessed by users across the network. In addition, the design as a server farm is very critical to ensure the high availability, scalability, and reliability. This is the key consideration when designing a server farms. Okay. Next, we have the ISP, Internet Service Provider, plays an important role in a network design by providing a necessary connectivity to the Internet for organizations and individuals in network design. The ISP is responsible to providing Internet access. We also have firewall. A firewall is a very critical component of network design, as it serves as the first line of defense against cyber threats and is a security device that monitors and controls incoming and outgoing network traffic based on determined security rules. Its primary function is to block unauthorized access while allowing authorized traffic to pass through. It is critical when designing a network. The firewall is a typical deployment at the network perimeter to protect the internal and network from external threats, as allows in the pictures. Okay. And we also have the switches. Switches are an essential component of the network design as they provided connectivity between network devices, allowing them to communicate each other. A switch is a network device that connects devices together on a local area network by using packet switching for forwarding data to its destination. When designing a network, switches are deployed in different parts of the network to connect devices such as a server, workstation, and other network equipment. Then next we have wireless AP. Wireless access points are very also important component of network designs as they provide wireless connectivity. Okay. When designing a network wireless, AP are deployed in different parts of the network to provide wireless coverage to different areas of organizations and to ensure all areas are in coverage. Network computers. Basically, network computers or a workstation is a very essential component. And now let's go dive into another layer of such as a network users. Assessing a number of types of views that will generate network traffic is an important step in network design, and as it can help determine the appropriate network infrastructure needed to support the organization's needs, and some of that can be taken as assess the number of types of users that will generate network traffic is to identifying user groups in Active Directory, determine users' activities such as the database, email, videos, and social medias, to assess the traffic patterns, computing the estimate bandwidth requirements, and lastly, by considering future growth. Okay. Future network upgrades will require understanding of a use of a new applications by increasingly flexibility, improving productivity, enhance collaborations, increase security risk, and cost savings. And these are the effect of the use of hybrid work platform, such as the VPN, video meetings, interactive business solutions, and cloud computing setups. The next, hardware network design is a process of allocation of hardware specification in developing a physical hardware network infrastructure that consists of network hardware such as a router, switches, servers, and other devices. The goal of hardware network design is to create a reliable, efficient, and scalable network infrastructure that can support organizations' business needs. That based on the possible network designs by specifying the server application and compute allocation based on the system requirements to support the applications and users' needs. To specify the switches and access points requirements by computing the system network traffic comes from the database, systems, and other business solutions. And also to specify the circuits, cable standards connected to the computers. And by using the best practice equipment brands based on the global standard. The deliverables in network design depends on the scope and complexity of the project, as well as the specific needs of the organizations. However, some common deliverables in network design includes the network diagram, network requirements document, network architecture design document, IP addressing scheme, network security plan, implementation plan, operations and maintenance plan, network testing and validation report, and users documentations. And lastly, the most important is the total cost. Cost assessment is a critical aspect in network design. It helps the organization to evaluate the financial implications of different designs options and make informed decisions about network investments. And here are the complex process when conducting a cost assessment in network design. List circuit cost and purchase cabling, networking devices such as switches and routers, hardware costs such as server, hubs, NICs, and UPS, the software cost, network operation system, application software, and middleware. We also have network management cost, including the special hardware, software, and training needs for network management. Maintenance costs for monitoring equipment and support on-site repair. And operation costs to run the network. Okay, the service level agreement is to establish between organization and common telcos carrier and ISP. Specify the exact type of performance that common carrier will be provide. Then availability, 99% can be downtime of 3.65 days per year with no penalty. Okay. And then 99.9, it can be down for 8.76 hours per year with no penalty also. It depends upon what is the service level agreement between the telcos. Okay. It's also maximum response time and other parameters. And then it's specify penalties if the desired performance is not yet provided. The overall key points in network design is by ensuring that the network is designed to meet the organization needs while it's also being secured, scalability, reliability, performance, and manageability. And most important, it must have a room for future expansion. I think this will be the end of my presentation. Thank you very much for listening and have a good day.